Section 2 in Chapter 3 is titled Solving Inequalities by Adding or Subtracting. So we're just going to look at some examples where we need to solve the inequality and then we want to graph the solution. Remember that solving inequalities is very similar to solving equations. So first, in this inequality, m minus 6 is greater than negative 4. We want to get the m by itself. So it has a 6 being subtracted from it, so we want to add 6 to both sides. That'll give us m is greater than 2. Once the inequality is solved for the variable, you have the variable on the left-hand side, then you can go ahead and graph. So we're at 2 on the number line. We want an open circle since we're not including 2 because it's greater than, and we want to shade to the right. Remember, you can look at the way that the inequality symbol points. It looks like it's pointing to the right. Or recognize we're talking about all values greater than 2. Try this one on your own. 7 is less than 4 plus c. So here we have 4 and c being added together. So we want to subtract 4 to the other side. That's going to leave us with 3 is less than c. We do have the inequality solved for the variable. Remember though, however, I like to write the variable on the left-hand side so that I can look at the symbol for my shading. So when we rewrite it, 3 less than c becomes c is greater than 3. So we're at 3 on the number line. We have an open circle again because we are not including 3, and we are shading to the right. P minus 4 is less than 1. So what do we do here to solve the inequality? We add 4 to both sides. So we get P is less than 5. The inequality is solved. We have the variable on the left. Again, we are not including 5, less than, and we shade to the left. Example 4, we have 3 over 2 plus w is greater than or equal to 2 1/3. So here we have a lot of fractions. Remember, the easiest way to get rid of fractions or to deal with fractions is to get rid of them. But before we can figure out what to multiply by, I'm going to change that 2 1/3 to an improper fraction. So the inequality I'm going to write is 3 over 2 plus w is greater than or equal to. Remember, when you change a mixed number to an improper fraction, you do the candy cane method. Some of you maybe have heard 2 times 3 plus 1. So 7 over 3. So now the question is, what can I multiply everything by to get rid of those fractions? Not a 2 because 3 doesn't go into 2, and not a 3 because 2 doesn't go into 3. So what number do 2 and 3 both go into? And it's 6. So we're going to multiply everything by 6. So here, the 2 reduces with the 6 to a 3, so I have 9 plus 6w is greater than or equal. This becomes a 2. 2 times 7 is 14. So 9 plus 6w is greater than or equal to 14. Now when I solve, I subtract 9 to the other side. So I have 6w is greater than or equal to 5. And now I want to divide both sides by 6. So we get w is greater than or equal to 5 over 6. So we plot 5 over 6 on the number line. That'd be somewhere between 0 and 1, closer to 1. This time we are including the point because we have greater than or equal to, and we're shading to the right because I have my variable on the left-hand side of the inequality statement. I can look at the direction of the symbol pointing to the right. Okay, so let's look at some statements here where we need to write the inequality and solve it, but we do not need to graph. So 4 more than a number is less than 11. So what I like to do on these is I like to go through and write everything that I'm talking about. So 4 is the number 4. More than means addition. A number, I'm going to call it x. Less than is the less than symbol, and then we have the number 11. So 4 more than a number is less than 11. We do have to remember one thing though about the word more than. it means that we have to flip-flop the two terms. So instead of saying 4 plus x, we're going to say x plus 4 is less than 11. We have written the inequality. Now we need to solve by subtracting 4 from both sides, and we get x is less than 7. If you'd like, you can try number 6 on your own. 6 less than a number is greater than 32. Or excuse me, 10 less than a number is greater than 32. So we have 10 less than is subtraction. Our number we can call x, greater than, and we're talking about 32. Again, more than and less than, those are the two where we need to flip-flop the two terms. So instead of 10 minus x, it's x minus 10 is greater than 32. So we have written the inequality. Now we need to solve it by adding 10 to both sides. And we get x is greater than 42. Okay, more of a real world type example here. Again, we need to write the inequality and solve, but we don't need to graph. Your baseball team has a goal to collect at least 160 blankets for a shelter. Team members brought 42 blankets on Monday and 65 on Wednesday. How many blankets must the team get on Friday to meet or exceed their goal? So we want to collect at least 160 blankets. So that's what everything is going to total up to. We have already collected 42 and 65. So 42 plus 65. We need to know how many more blankets, so plus x, until we meet or exceed our goal. So the question is, what symbol do we want here? We want to collect at least 160 blankets. So that means that over here on the left-hand side can be greater than or equal to 160. We can exceed the goal, but we don't want to go under it. So this value of x, when we solve the inequality, will tell us how many blankets we need to get to meet the goal of 160. Anything over that would then exceed it. So 42 plus 65, that's 107. Subtract 107 to the other side, and we get that x is greater than 53, greater than or equal to 53. So we need to get at least 53 blankets to meet our goal. Anything over 53 then would exceed the goal. In class, we'll work on worksheet 3.2. Just make sure that you understand how to solve inequalities when the steps required are addition and subtraction, and also being able to work with some real world or word type applications.